All right. So 7th graders, here's a little bit more on lesson 7-2. And this is a model for finding the answer to a problem that has to do with consecutive integers. Consecutive means in a row, okay? Like 3, 4, 5. Those are consecutive integers. What if it said consecutive odd integers? What would be consecutive odd integers? Give me an example. Max?
3, 5, 7.
3, 5, 7, right? Skipping 4 and 6, because those are even. Or consecutive even integers. 2, 4, and 6. Does that make sense? You understand what consecutive means? Consecutive means what, class? In a
Order.
in a row.
Row.
In order.
Yeah.
Okay? And consecutive means that we're not skipping any. Integers means that they are whole numbers. So we're not talking about 2.5, 3.5, and 4.5. These are integers, whole numbers. Okay? Now, yes, you have to write this down. So funny. Now, the problem that you're going to have to solve sounds like this. Find 3 or 4. Let's do 3 consecutive integers. Here's an example. Find 3 consecutive integers that equal a sum of 96. Okay? 3 consecutive integers that equal a sum of 96. Here's how you set up this problem. First of all, you choose a variable, and we're going to choose the number n because it stands for a number. In this case, it's the first number. So write this down. N equals the first number. Okay? N equals the first number. Okay, so write this down in your notes. N equals the first number. Okay? Now, I want you to think now, if n equals the first number, then the second number can be expressed by writing n plus 1, right? Because if the number was 3, 3 plus 1 is 4, the next number. So we could write an expression for the next number as n plus 1. And an expression for the third number as n plus 2. You with me so far? No, just wait. Do you understand what I just told you? So we can write n plus 1 to represent the second number, and n plus 2 to represent the third number. Okay? Would that make sense if these were our numbers? If n equals 3, then the second number would be n plus 1, and the third number would be n plus 2, right? I know I'm covering that up so that you can listen and follow along. Does that make sense? Nod your head if that makes sense. Okay? Now, if we use these as our numbers, instead of the actual numbers, if we use these as our numbers, how could we write those together to equal a sum of 96? What does sum mean? The answer to a addition problem. In other words, if we added them all together, they equal what? 96. Now, how do you write them added all together, Caleb? How do you write these added all together? Right? So this is the first one, this is the second one, and that's the third one, right? That's these numbers added together. N plus n plus 1 plus n plus 2. And we know that those equal, what, Amelia? 96, yep, good. Now, let's simplify this. In other words, let's combine like terms. So, what can we add together? All of the what, Emily?
N.
All of the n's. How many are there, Grace?
3.
3. So 3 n's. And what else can we add together, Jordan?
3.
Yeah, the 1 and the 1 and the 2. That equals 3. So we can simplify this expression as 3 n's plus 3 equals 96. Are you with me? No? Can you see that from back there?
Not really.
All right, come on up here.
I'm fine, because I can read like the basics.
Okay, or you just listen and follow along? All right, I'll be watching. Now, what would you do then to get rid of the 3, Luke?
Divide by 2. So by 3 and
No, just the 3, not the 3n. We have to get rid of the 3 first. We have to get
plus.
the variable term by itself.
Plus negative 3.
Plus negative 3, right. What would you do, Emily?
Get 3.
You just said you were going to listen.
I am, but this is boring.
That doesn't matter. What does that have to do with it? You told me you were going to listen. Alright, come on up here. It'll be less boring if you're closer to the board.
No, it'll never.
No, I really trust you. You got this.
It's like a game.
This is, yeah, come on down.
You win. Let's cry.
Okay, now, come on up. We're going to add 3, actually add negative 3 to both sides. Where? This is going to be less boring if you're in front of everyone. Okay, so, here's the 3. How do you get rid of this 3, everybody? Okay? She's on the spot. Okay? Now, add what? How do you get rid of that 3? Add negative 3. To where? No, just tell us.
Add negative 3 to like the board.
To this side. Say to this side.
This side.
And then add negative 3 to
Other side.
this side. Yeah. So, what is left? When you add negative 3 to this, what do you have left? Quiet, please. 93, right. 93. So, what is left on the left side? Just the 3n. And what's left on the right side? 93, right? You with me? Isn't this a lot less boring though? No. Really? We have to do more. Okay. Alright, let's do it. Now, just keep warming up, people. What would you do to the 3 n's to get 1 n? Emily.
2.
No, you can't minus 2 n's because we don't have 2 n's on this side. What we're going to do is put it into a group. How do you group things? What operation groups things? Sammy. What operation groups things? No, putting into groups.
Operation.
When you're putting into groups, what operation is that? Is it subtraction?
Addition.
It's not addition, it's
Division.
division. We have to do what? Divide by, quiet please. This is important.
3.
You have to divide by 3 on this side, right? How many groups of 3 ends can you make? 3. No, think.
1.
You can make 1 group of 3 ends. Okay? And if we divide this side by 3, what's left is 93. Yeah, 93. If you divide that by 3, you get what? 93 divided by 3, Asa. 31. It even says it right here. N equals 31. So you should read before you.
Maybe he thought it was a 2.
Okay?
Maybe he thought it was a 2.
So 31. And that's the what? What is N? N is the first number. The first number is what? Oh, what is that? 31. So what are the consecutive integers?
Oh, 31, 32.
Right, 31, 32, and 33. Okay? 31, 32, and 33. 31 plus 1 is 31. 31 plus 2 is 33. That's how we get the consecutive.
You said 31 plus 1 is 31.
Nope. 31.
That's what you said.
Oh, I'm sorry. 31 plus 1 is 32. And 31 plus 2 is 33.
Like,
Okay? Thank you, Leslie. Alright, now, what you're going to do is, oh, we already covered the distributive property. Remember, you multiply over the parentheses. But on page 359, there's this problem. The consecutive integers. Nope, come back. No, you didn't. No, I got this.
Yeah, it's so awesome. It's okay.
Alright, look.
It's
Page 359, number 24. Okay. I know. Now I'm going to show you how to prove it. Okay? Page 359.
Is this in our notes? Oh, this is my.
That's will be in your notes when we're done. Okay. Now, when you do this problem on Friday for the quiz, when you do a problem like this on Friday for the quiz, you're going to have to set it up this way. Okay? You need 4 numbers. So one of them is n. What are 3 more numbers that you can write as expressions? The first one is n. The second is what? N plus 1. Good. N plus 2. Plus 3. Right. Good. So start with that. Anytime you need 4 consecutive integers, they're just going to be 1 plus 1 plus 2 and plus 3. What if it said consecutive even integers? Then it would be n plus 2, and n plus 4, right? Okay, now listen, stop talking. What if it said consecutive odd integers? Whoa, wait a second. But if this was an odd integer, let's say this was 5. If we had 1, that's going to give us 6. So we have to get 2 again to get 7, and 4 to get 9. So we're still adding 2 and 4 even if we're looking for odd integers. Right? Because we're still just skipping the next one and the third one. Okay? Does that make sense? Alright, now. We're going to add these together to equal negative 22. So now I want you to think, Emily, you can go get your paper. Okay. Now, write down an expression that equals negative 22. She's getting her pencil. Write down an expression, everyone. Yeah, write down an expression on your assignment that equals negative 22. 4 consecutive integers that equal negative 22. You can do this.
We have the answers right there.
The answer is not here. Write the expression, or actually the equation. Write the equation for n plus 1, n plus 2, n plus 3 equals number 24. Come on. No, write the equation. So it's n. We just did this before.
All the answers.
Let's do it right here. N plus 1 plus n plus 2 plus n plus 3. On the quiz on Friday. I'm just being honest. Okay, now add the number. Add the ends. Add the ends. How many ends are there, Garrett?
There are 1, 2, 3, 4 ends.
So combine the ends and write the 4 ends. Johnny, how many numbers are there? Add the numbers now. Quiet, please. 7. 1 plus 2 plus 3 is 6. So 4n plus 6 when we simplify this. And it says, quiet please. Oh, I know, I forgot to give you the extra assignment. No wonder it was out of control. 37 to 47. Okay? 37 to 47, page 360. Now, that equals what? Asa?
N equals 6.
No, look at the problem. What is it going to equal?
4n is 4 and plus 6.
Oh, what does it equal in the problem?
Negative 22.
Negative 22. You have to write negative 22. Okay. And you're not writing it down still.
He's a math teacher.
Why do we have to do this every day? This routine, this little game that we play. Okay? I know. Calm down. Yep. Okay, now get rid of the number. How do you add the number? How do you get rid of the number on the same side as the variable? You get the variable by itself, Sam.
You have to add 6. You have to plus negative 6
Plus
each side.
Each side. Good. Emily, what is that? 0 and okay, negative 22 plus negative 6. So, simplify down, Laura. We have how many n's left?
4.
4 n's. And they equal
-28.
-28. Yep. Now, how do we get the first number? Merlin.
How do we get the first number?
Yeah, we've got the first number. We know what the answer is. How do we get it?
You have to divide by 4 on each side.
Good. Divide both sides by 4. This leaves one n, one group of n, and one group is -7. So then look, if one n is -7, then n plus 1 is
-6.
-6. And -5 and -4, right? Any questions on this process? We're learning a process here, okay? We're learning this process. Any questions about it? Okay, good. Go to lesson 3 then. Yep, lesson 3.
Wait, so we don't have an assignment in that?